Welcome to This Explainer. Today, we're going to dive right into the science of natural disasters and uncover the exact formula that determines our actual risk. We constantly watch the news and see these devastating clips of storms or earthquakes, and honestly, it can feel like nature's just inherently out to get us. But is that actually the scientific truth? Let's find out.
Okay, let's kick things off with a provocative question to kind of challenge what we think we know about the forces of nature. Does a massive magnitude 8 earthquake automatically cause a disaster? Just think about that for a second. If the earth violently shakes in the middle of a completely uninhabited desert where there are literally no people, no buildings, and no infrastructure, is it a disaster? Well, science says no. It's actually just the earth being the earth.
So here's our roadmap for this explainer. 1. When nature becomes a hazard. 2. The disaster risk formula. 3. Defining vulnerability and exposure. 4. The true cost of disasters. And 5. Reducing our disaster risk.
Let's jump right into section 1, when nature becomes a hazard.
It is absolutely crucial to understand that natural phenomena, things like typhoons, volcanic eruptions, and earthquakes, they've been happening since the very early days of Earth's history. Long before humans were even around, there were no disasters to speak of, at least not from our perspective. These are simply natural events. They only become hazards under very specific circumstances, mostly when human beings and all of our stuff are put directly in their path. So an earthquake in an empty desert, that's an event. That exact same earthquake near a bustling city, now that is a hazard.
Think about a weak, cracking concrete fence. If it's just sitting all alone in an empty lot and collapses with a slight breeze, it doesn't pose a threat to anybody. But the very moment you park a car right next to it or a person stands beside it, the threat of damage or injury suddenly pops into existence. The fence itself didn't change, right? Its proximity to something valuable did. And that is exactly how a natural event transforms into a hazard. Moving right along to section 2, the disaster risk formula.
So, disaster risk isn't just about extreme weather or shifting tectonic plates. It actually breaks down into 3 specific interlocking puzzle pieces. First, you have the hazard itself. Second, exposure. And third, vulnerability. You literally need all 3 of these ingredients in the mix to brew up a true disaster.
Just picture how this recipe comes together. If you have a natural event, like a massive flood happening near a vulnerable population, but their paths never actually cross, you've got zero disaster. It's only when that hazard perfectly overlaps with those people that a disaster strikes. It's a literal collision of nature and human presence. Which brings us to section 3, defining vulnerability and exposure. Let's start with exposure. This refers to the people, the property, and the infrastructure that are physically present right in the path of a hazard. Historically, our exposure has grown tremendously. As human populations expanded, our urban centers grew uncontrollably into areas that are naturally prone to severe events, places like coastal zones, floodplains, or even the slopes of volcanoes. Literally, just being there, that means you are exposed. And then we have vulnerability. This refers to the specific factors that increase your susceptibility to that hazard's impact. And it's not just physical, like living in an unreinforced, poorly built home. It's also social and economic. Interestingly enough, if your vulnerability is essentially zero, even a massive hazard might not translate into a disaster. For instance, if a coastal city has perfect storm surge walls, brilliant early warning systems, and total population compliance for evacuation, a super typhoon is going to hit, for sure. But it might just end up being a severe weather event rather than a catastrophic disaster. All right, so here is the real game changer, the equation itself. Disaster risk equals hazard times exposure times vulnerability. Notice that it's multiplication, not addition. Mathematically speaking, if any single one of these 3 factors is 0, the total disaster risk is completely nullified. If there's no hazard, risk is 0. If no one is exposed, risk is 0. If you're exposed but have 0 vulnerability, your risk is 0. This whole model helps us express the chances of a disaster happening while also letting us quantify its potential impact. Now let's dive into section 4, the true cost of disasters. When those circles do overlap and the equation results in a high risk, the reality is immense, heartbreaking devastation. Disasters often leave practically 0 lead time for preparation or evacuation. Take the 2004 Indian Ocean tsunami, for instance. It completely wiped out a wealthy area in Aceh, Indonesia, with almost no warning. Disasters don't just damage a few homes. They can completely alter the entire landscape of a community in just a matter of minutes. And these impacts, they're a massive domino effect. They demand intervention way beyond what a normal government capacity can handle.
We're talking about medical systems getting instantly overwhelmed by traumatic injuries and sweeping diseases. Critical lifelines like communication installations and power lines are completely severed. Transportation basically grinds to a halt with impassable roads and broken bridges, which severely restricts rescue operations. And economically, everyday business operations are totally disrupted because folks have to drop everything and focus entirely on survival and search and rescue.
But it goes way beyond just physical damage. Disasters also expose some really deep social and political inequities. Developing nations often suffer the most because the poorest populations are frequently forced to live on marginal, highly dangerous lands. What's truly wild to think about is how this can literally reshape history. For example, the breakaway of East Pakistan to form the state of Bangladesh was actually triggered by the massive fallout and the exposed inequities right after a devastating tropical cyclone and storm surge. Disasters can literally redraw maps on a global scale.
Finally, let's wrap up with Section 5, reducing our disaster risk. A great way to think about this is through an analogy. Preparing for a disaster is very much like training for a huge professional sports match, say boxing or basketball. To get that win, you have to meticulously study your opponent's abilities and their flaws. By scientifically studying the nature and character of a hazardous natural phenomenon, we can actually figure out the necessary defensive maneuvers to take evasive action.
So, bringing it all together into that intersecting puzzle we talked about earlier, we literally cannot control or shrink the hazard circle. Nature is going to do what nature does, right? But through mitigation and preparedness, we can actively push back on those other two circles. By physically shrinking our exposure and reducing our vulnerability, that central overlapping area, the actual disaster risk, becomes significantly smaller. Now, I know what you're thinking. Why don't people just leave? Well, pulling folks out of that exposure circle is incredibly tough in reality. You can't just blindly order a community to relocate. People naturally resist moving. They fear losing their ancestral homes and their livelihoods. There's also this psychological barrier where people develop a false perception that disaster events are cyclical, falsely believing that surviving a major event guarantees them a long, safe period afterward. And most pressingly, poverty often forces people to stay in dangerous areas, like highly fertile volcanic soils or active floodplains, because the daily risk of starvation is a much more immediate threat to them than some potential future disaster. But despite these massive challenges, there's a quote that brilliantly wraps up the whole shebang of this explainer. We simply have to accept that the occurrence of natural events cannot be prevented. Our power, our true agency, lies entirely in how we manage the human side of that equation. By strategically reducing our exposure and tackling our vulnerability, we can absolutely minimize their deadly impact.
So, I want to leave you with a question to really chew on and apply to your own life. You can't stop the storm from forming, and you definitely can't stop the ground from shaking. But knowing the exact math behind a disaster, what active steps can your neighborhood, your family, or your broader community take today to shrink your exposure and your vulnerability? Because ultimately, whether a natural event becomes a full-blown disaster is largely up to us.